All right, so this is Chapter 1 review. We're covering parts 1.3 and 1.4. This is part 1 of the videos. So we're asked what are the three most standard formats of linear equations. We have the standard form that shows up in mostly in academic settings, like in books or in academic papers. There is the slope-intercept form, which is the y equals mx plus b, where m is our slope and b is our y-intercept, and point slope, which is y minus y1 plus, or equals slope of times x minus x1, where x1 and y1 are an actual point and m again is our slope. So determine whether the following data indicate the function is linear or not. And I've gone ahead and figured out the values to see whether or not they're the same. So here, if we take a look at this one to this one, we have 25. The second one to the third one, we have 25. So far, it's looking like it might be linear. Though, as soon as we get to here, we're talking 11 and then 20. This is definitely not 25 or even 24 or 26. I mean, if we're talking real-time data, real-life data, you might expect it to be 24 or 26 instead of an exact 25. But in this case, it's clearly not. So there's definitely something more happening here. So this is not linear. Okay, so we're going to say not linear. Now if you take a look at this one, we're going up by tens. And on each of those tens, I am going up 29. So because they're constant, right, and because we're only given this much data, we can assume that that's the only data we need to look at. This is going to be a linear function, and you could call it 29, which is my change in the y, right? This is my delta y, and here's my delta x, right? So delta y over delta x is going to be my slope. Here, so I have 29 over 10, or I could say 2.9, or 2 and 9/10. Anything along those, any one of those would be acceptable. All right, let's truck along here. So what is the slope of the line in the equation y equals 6x plus 4? And this is one of those cases where it might be real easy to overthink something. We're asked for the slope of the line, and we're given an equation. Well, the slope of the line in a slope-intercept form is right here, right? This is our slope. So 6 is our slope. Okay? Another one, right? If you have the slope of the line in the equation, f of x equals negative 2 over 5x plus 4, the negative 2 over 5 is going to be our slope, right? Again, don't make it harder than it needs to be. We tend to do that with mathematics. I'm not entirely sure why we do that, but we tend to want to make things more difficult than they need to be so that we have, I don't know, so we feel like we're accomplishing something. I don't know, but for whatever reason we do it, we frequently will make math harder than it needs to be. All right, so we're asked for the slope of the line that passes through these 2 points, 16 and negative 13, and negative 8, negative 5. So I'm going to go ahead and take remember my y1 minus y2 all over x1 minus x2. Right, as long as we keep the pair together, we're good. So I can go 16 and negative 13. Let's go negative 13 minus negative 5, right? So there's my negative 13, there's my negative 5. I'm subtracting those two. and I'm going to have 16 minus negative 8. All right. So here, remember, I have my double negatives going on. Remember, I can change the operation to its opposite operation. So for subtraction, I can make this addition as long as I also change the sign of the number following that sign. So here becomes a positive and here becomes a positive. So negative 13 plus 5 is going to leave me a negative 8. And 16 plus 8 is going to get me 24. Which, okay, this looks great. Except now you might spot, okay, there's 2's in there, there's 4's in there. You might even spot that there's 8's in there. So if I divide both of these by 8, I'm going to have a negative 1 over 3. All right, so our slope on this one is a negative 1/3. Now on this, I'm going to point this out, and this is one of those where the notation seems to throw people more than I would expect, but it does throw people pretty profoundly. So I'm going to just address this real carefully. So here I'm saying my y is equal to negative 5, and here I'm saying my y is equal to 1. All right, because this is my f of whatever that value is, and here's my f of whatever that value is. So whatever that value is my x, right? So in this case, my x equals a negative 4, and my x equals 4. So my ordered pairs, well, first of all, I'm going to have, my ordered pairs on this are going to be negative 4, negative 5, and I'm going to have 4, 1. So from here, I'm going to go ahead and set up my slope formula. I'm going to have my 1 minus a negative 5 all over 4 minus a negative 4. So I'm going to have a 6, right, because that becomes a positive, over 8. And the 6 over 8 can reduce to 3 over 4. So my slope is going to be this right here, 3/4. So what is the slope of a horizontal line? And how do we know? Well, a horizontal line, does it go up or down at all? The answer is no. So there's no rise to the run. Right? Remember, slope is rise over run. Well, if there's no rise to it, that means it's a 0. So our slope in this case is 0 because the line does not increase or decrease. Okay, so as far as we're talking about with the y, I'm saying it doesn't increase or decrease, and I'm saying I'm trying to be specific that that I'm talking about the x values are not increasing or decreasing, right? Because certainly our x values can be any real number, so that could definitely increase or decrease. All right, so what is the slope of a vertical line, and how do we know? Well, on this one, I'm going to say I'm going to go theoretical for you, and then we're going to talk about the practical, the actual vertical line. So here I'm saying if I have my vertical line, I'm saying that x is, I don't know, say x is whatever. And then we've got 1, and then I've got x and 7. Okay, so whatever this x value is, right, it's the same value for both places. So I have x equals x, right? So when I say x minus x, that's going to give me a 0. Well, on my slope-intercept form, I have y1 minus y2 all over x1 minus x2. Well, that would be this piece here, which means that I'm going to have y1 minus y2 all over 0. And we all know that we cannot divide by 0. So this was going to be m is undefined. D-E-F-I-N-E-D. All right. Never said English. Spelling was my strong suit. Okay, so what is the slope of the vertical line? Well, it's undefined. And how do we know? Because x values are the same. Making us try to divide by 0. And that's when we say, oh, no, we can't do that, right? Alrighty. Find the equation of the line that's parallel to y equals 4x plus 2, and it passes through the point 5, 9. All right. So I'm going to give you both ways you can go about this. I'm going to go with what's probably the easiest way first. All right. I'm going to do actually the point slope form on this one. I have my y minus my y over here is going to be the 9, is going to equal, well, I know it's parallel, so its slope has to be the same. So it's a 4 over x minus 5. And that is a complete statement, right? Find the equation of the line parallel. This is the equation of the line, right? It's parallel to this line, and it definitely goes through this point. Right, so if you're like, okay, I absolutely hate the point slope form, I'm not going to use that, I want to use my slope intercept form, here's how we would go about addressing that. So we're going to say, I'm going to replace the 2 with a b, so y equals 4x plus b, since it can't have the same intercept. All right, so we're going to plug in the 9 and the 5. So I have a 9 equals 4 times 5 plus b. 9 equals 20 plus b. And when I subtract my 20 to the other side, I wind up with b is going to equal negative 11. So my equation of the line on this would be y equals 4x minus 11, or you could say plus a negative 11.